Welcome to Midnight Coding. Today we will solve LeetCode problem 207 course schedule. This is a graph problem, but before we continue, please like this video as it will give you all the luck you need to land your dream job. And just as an extra measure, subscribe to the channel and I promise you will succeed in your endeavors. And also, it encourages me to keep making educational content like this. Now, let's follow our 5-step process. Now, let's understand the problem. So we are not given the number of courses and what they are, and we're given the output. So the reason why this is true is that to take course 1, we have to take course 0 first. So the ordering would be this. So this is pretty intuitive and easy to understand. But once we see the next example, we're gonna really understand what this problem is asking us. We are given the number of courses 2. So we have 1 and 0 and the same for this one. So the reason why this is not possible is that to take course 1, you gotta take course 0. And to take course 0, you gotta take course 1. So you can imagine that there's a cycle in this graph. So since there is a cycle, this is not possible. And that's basically what the question is asking us. Is this possible to schedule this? And the only condition that it's not possible is that if there's a cycle in this graph. So now let's come up with our own example. So in this case, the number of courses would be 4. To take course 8, we gotta take course 7. And to take course 7, we gotta take course 2 and 3. So the ordering would be possible. It would be 2, 3, 7, 8, where we take course 2, 3, 7, 8 in order, and this would be possible. However, this would not be possible if 3 was pointing to 2 and 2 was pointing to 8. Now what this means is that to take course 8, we gotta take 7. To take 7, we gotta take 2. However, to take 2, we gotta take 8. Now, this becomes not possible. With that in mind, let's think about how we can solve this. Since this is a graph problem, we can come up with a number of solutions. We have DFS and we have BFS. Depth first search, we can go to all the paths in depth and then we're gonna say, for example, when you get to 2, are we visiting any of the nodes again? We go from 8 to 7 to 2 and we're asking, does 2 point to 7 or does 2 point to 8? If it does, return false. If it not, continue. That's a possible solution in depth first search. In breadth first search, we can also do the same thing. We can go level by level and ask the same question and it will work. However, in this problem, we are going to use something called topological sort. Topological sort is a special graph algorithm that we use to detect cyclic graphs if there's a cycles in a graph or any sort of problem that has dependencies on each other, such as course scheduling. From what we saw earlier, like course A is dependent on course B and course B is dependent on course C. So this is a dependency problem. So we'll be using topological sort to solve this. So this is how we are going to use topological sort. We have our graph and then we have a variable called in degrees. So now let's think of what they are. So for example, at vertex 8 or node 8, we have an edge to vertex 7. So in our graph, we're going to say something like this. And for 7, we have 2 vertices, 2 and 3. So we're going to say, and so on. So that's how we're going to populate our graph. And in degrees is basically the count of how many incoming edges we have to a given node. So for example, 8 has 0 in degrees, meaning that there is no nodes that are coming to 8. However, for 7, there is 1. We have 8 coming to 7, and the same for 2 and 3. However, if there was another node, let's say 10, and if it was pointing to 2, we were gonna say that 2 has 2 in degrees. In topological sort, we have sources and we have sinks. Sources are basically all the nodes that have 0 in degrees, such as 8, and sinks are any nodes that have no outgoing edges, such as 2s and 3s. So topological sort starts with sources and ends with sinks. And now let's take a look at how this might work. I'm going to define a result variable and I'm going to take the source, which is 8, and I'm going to put it in my result variable. Now that I have taken 8, I'm going to take it out of my queue. So this would be a breadth first search algorithm, and we'll be using queues. Now that we've done that, 7 no longer have in degree of 1, it has 0. Now it becomes our source. And we're going to do the same thing. We're going to take out 7, and then now 2 has no longer an in degree of 1, it has 0, and it becomes the source. And the same with 3, then we know that we are finished with our loop because we have no sources left to iterate through. Now you can see that the length of our result is 4, which matches the initial number of courses that we've given in the first place. So this is how we're going to utilize topological sort to tackle this problem. Now let's start coding. Here's the solution to the problem in Python. As we discussed in our drawing explanation, we will be using topological sort to solve this problem. Topological sort makes this problem really easy because not only it gives us the actual ordering of the course schedule, we can use that knowledge to us and see if we can solve this problem or not. And remember that we're only printing true if it's possible, false if it's not possible, and false meaning that there is a cycle in a graph. Now let's initialize our variables. So we need a graph variable and we need to know the in degrees of our graph. So the Pythonic way of saying this is initializing this is that graph I is going to equal to an empty list for I in range of number of courses, and the same for in degrees. However, we only care about the number of degrees. Now that we've initialized our variables, let's populate. So for prerequisite and prerequisites, so the parent and child, or A and B, for the sake of this problem, to make this readable, so let's say course to take and course prerequisite. So course to take is at index 0 of prerequisite, and for prerequisite is at index 1. So now we're going to say graph at course to take dot append course prerequisite, and we should increment our in degrees variable. So now we need to know what are the sources are. So in Python, I'll just say collections.deck. It's going to be a queue. So we're going to say for key in degrees at this key equals 0, meaning that there are no incoming edges to this node. That means that it has to be the source of this graph. So we're going to say sources.append this key. Now that we know what the sources are, we're going to do a while loop. While we have sources in our array, our vertex or our node that we're looking at right now, so I'm going to call this a vertex. So the vertex is going to be sources.pop left because this is a queue. We're going to define a course schedules array where it's going to tell us what the ordering is, right? So for example, in this case, number of courses is 2 and prerequisites is 0 and 1. So it'll be 0 and 1 in this case, but we're not interested in that here, but we are going to use this array to see if it's possible to make this schedule or not. So we're going to append this vertex to our course schedules, and we're going to say for child, or let's say for neighbor in graph of this vertex, we're gonna say in degrees of this neighbor is decremented by 1 because we just popped the parent node. And then we're gonna say if the in degrees of this child becomes 0 at some point, then we must make this a source. So now that we've done that, now we just gotta make sure that the length of our course schedules equals to number of courses. So what that means is that if the length of course schedules, if the number of courses equals to whatever ordering we have here, then that means that we have no cycles in the graph. But if it's not, that means there are cycles in the graph. So in this example, as you can see, number of courses is 2 and the ordering should be 0 and 1. And over here, you can see number of courses is 2, but as you can imagine that there's 1 and 0 and 0 and 1, and the length of courses schedule we're going to schedule is going to be different than the number of courses because the length of whatever we're going to get from here is not going to be 2. So that's how we can determine if it's possible or not. So let's run the code and see if it works. Now let's submit it, and it works. So this is the solution to the problem using topological sort in Python. So I hope you learned something new today. And step number 5 is that at the end of our interview, we're going to have to think about more edge cases and then how we can optimize our solution in a better way. However, on LeetCode, we note that we have passed all the test cases. However, in our actual interview, we would want to come up with different edge cases. And then we have to think about how we can optimize our solution so we can show our interviewer that we are thinking of optimizing our solution in a better way. However, for this problem, topological sort would be as optimal as it would get. So with that being said, I hope you learned something new today, and I'll see you guys soon.